and you shouldn't probably take everything as absolute gospel truth either. There is some science in here, but there's also quite a bit of speculation and quite a bit of conspiracy theory. So I hope you can cope with all that. So let's get started. The far side of the moon, is it just aliens, is the name of the talk. And I wrote it originally for the Apollo 50th landing on the moon series at the University of Nottingham. So I've just sort of extended it since. So the sort of prerequisite is that we can see the near side of the moon. We've all seen that. Everybody's seen the near side of the moon, and we're all very familiar with it. And despite many, many conspiracy theories, we've actually landed on it, and 6 times, and brought back moon rocks, astronauts, pictures, and science data from the far side, from the near side of the moon. But the far side of the moon, due to the particular dynamics of this situation, there's always been a mystery. And whenever you have something hidden away that people can't see, they always tend to come up with theories as to why that can't be seen. And the sort of wackier side of the internet certainly come up with the idea that it's probably full of aliens or other things studying us, because, well, what are they trying to hide? Why is the moon always hiding the far side away from us? And this has certainly been the case throughout the years. Even recently, this is the Daily Mirror, not the highest quality newspaper in the UK by any means. So this is 2016, and they claim that UFO experts have found giant castles on the moon. Can everybody see that giant castle there? There's a huge castle there. And if we zoom in on it, there we go. There is clearly a castle on the moon. That why aren't the government telling us about this? If we go back further into, this is, I have to say, UK media once more. There's another one here from, I think this is 1988. And now this is a classic tabloid publication, not known for its rigorous journalistic abilities, as you can probably see there. They claim that there was a World War II bomber found on the moon, and there's even a little picture of it there you can perhaps just see. Now, if we look at the actual evidence for it, there is the evidence of a picture. And you might note that all these pictures of strange things are always taken at the very limit of the resolution of whatever it's being taken with. But this didn't really stop this newspaper called the Sunday Sport, which had many, many crazy headlines. And this was just one of them. Most of the others are probably not suitable to actually even include in this talk. But they had the ability, obviously, to zoom in and enhance like any good CSI type program, and that's what they did. Now, I think this is probably more Photoshop than photorealism, but there we have a picture of the World War II bomber on the moon. I think this is an American B-17, but if you know anything about the moon, you probably know that crater is about 15 miles across or something like that. So you know, this would be in a huge aircraft if it was indeed on the moon. Stranger still, they had another headline not long after that said that it now vanished. So there we are, that's the journalism at its finest. And they had many other headlines. There was a famous one that a London double-decker bus was found buried at the South Pole, and a statue of Elvis on Mars. So there's plenty of newspapers and journalists there ready to fan the flames. The Transformers series had a dark side of the moon that had the Transformers living on the dark side of the moon. It's the perfect place to put anything that you want hidden because it's always out of view. But it's not even just the late 20th and 21st century that has done this. Back in 1835, there was a series called The Great Moon Hoax, perpetrated by the New York Sun and Sir John Herschel, although Sir John Herschel was not actually involved, it was just his name. And they claimed he had invented a brand new telescope that could now give outstanding images of the moon. And here are some of the pictures they included in the paper. We can see a few more here showing fantastic details of what was happening on the moon. So John Herschel at the time was actually in South Africa mapping the southern hemisphere, so he was not really aware of any of this, so they took his name in vain and perpetrated this moon hoax. And perhaps finally in this sequence, Pink Floyd, Dark Side of the Moon, a classic album. If you were around in the 70s and 80s, everybody had to own a copy, and sort of perpetuated the idea that there was a dark side of the moon. It's not dark, as I'm sure you all know. It has 14 days of light and 14 days of dark. And they do indeed say that on the album right at the very end, in the last few seconds of the track, that you can hear somebody saying there is no dark side of the moon really. As a matter of fact, it's all dark. Well, it varies between light and dark. So on to a little bit of the science, and I'm not, as Evelyn said, I'm more computer models of large-scale structures than planetary formation, but I always like to include a little bit. So what we know about the moon is that it probably started with a bang, that there was a big collision between something of about the size of Mars and the Earth, or at least that's the current theory. I've seen many other theories, and it has to be a particularly specialist glancing blow to actually achieve this. If this planet that was called Theia collides too full on with the Earth, then it just splits it apart and you just get a mess. And if it hits it at too much of a glancing angle, then it just bounces off and nothing much happens. So according to the computer modeling, it has to be an almost perfect collision. So that's why there is still some doubt about could this really be the case? And of course, the reason for the near side of the moon and the far side is tidal locking, that very soon after the moon entered its current position, it was subject to gravitational friction and tidally slowed down until only one side of the moon faces us. So this is why we now have this perfect conspiracy theory. But you can see the moon does rotate if you follow this around. See, it sort of rotates once around, so it keeps in perfect synchrony with it. It is not orbiting in a perfect orbit, though. It's not a perfect circular, it's an ellipse. So this is why we sometimes get supermoons when the full moon is at its closest point. But this does mean that it's going at different speeds around the orbit. So it's not always facing the Earth at just with one side. So we can actually see more than 50% of the moon. And this is helped a little bit by its being slightly tilted on its axis. So if you follow the moon over a period of time, which this animation hopefully will show, is that you can see it sort of wobbling as it moves around its orbit in the 28 days. So some craters right on the very edge of the moon do come into view just occasionally, and you can see them just slightly come into view. And this was very useful during the 60s, 1960s, when they were planning missions to the moon, because they could actually see a little bit extra of the moon. So you can see about 60% of the moon. So with that there, just a quick note on getting information back. This is why it's so hard, obviously, to get information back. And I'm sure this is not news to you, any of you. But if you put something on the far side of the moon, you are out of radio contact with the Earth, because you've got this huge lump of rock between you and the ground station. So you can't transmit through the moon. Radio waves won't go through that. So there are a few ways you can get around this. One is to put a satellite out here. But the problem with putting it right out there is that you can easily look around the moon, so to speak, and talk to the thing on the far side of the moon. But this is now in orbit around the Earth, being this far out. So it obviously drifts and very quickly disappears out of range. So it's not a great solution if you want to stick in good communication. The other place is obviously to put it in orbit around the moon. That works, but only at some points, only when you're sort of in radio contact with the far side can you pick up messages, and then only when you can see the Earth can you transmit them. So there's always going to be a period of radio silence. Now this impacts quite a lot on the first explorations of the far side of the moon. Remember, these were done, well, I'm going to tell you in a minute, they were done in the 1950s and 60s, and technology was not what it is today. That's why some of these people struggled. Of course, one of the solutions to this is to use the Lagrangian points, these places where the Earth and the Moon's gravity sort of null each other out. So there's 5 of these positions. L1 is a great place for a lunar hotel or a translunar hotel. It's somewhere you could go and stop on the way to the Moon because you could place a sort of hotel there as a satellite and it would stay there quite nicely. L2 is the perfect place if you want to communicate with the far side because it's far enough past the Moon that you can sort of see around the edges. L4 and L5 aren't particularly useful. And L3, just in case you're wondering, is the other side of the Earth. This is also true, obviously, of the Sun and Earth system. They also have the Lagrange points. And is a very favourite spot, L2, of putting some of the great space telescopes. So certainly Herschel, Kepler, and James Webb is going to go there. And pretty much all the more recent telescopes are going to end up there. They end up circling that, so it's a good place to be. L1 is a great place for solar telescopes, and L3 again is pretty useless because you can put something there, but you can't talk to it basically if it's there. So what do we know about the exploration of the Moon? Well, there's a series of probes that got closer and closer to the Moon. So Luna 1 was the first lunar probe, as you might guess from its name. It was a Russian probe launched in 1959 and was the very first probe to get anywhere near the Moon. It was designed to actually touch the Moon or crash into it, but they didn't quite get the course corrections correct, and it missed the Moon, but it got sort of within the Moon's sphere of influence. So this was the first ever probe to get anywhere near the Moon. It was followed up by Luna 2, which did land on the Moon. And when I say land, I mean crash. It made a big, well, a reasonable sized crater of its own when it hit the Moon. But this time they did get the calculations and the rocketry working. And so Luna 2 in 1959 was the first thing to actually touch the Moon out of all the things that we've sent over that way. First thing to see the far side of the Moon ever was this Luna 3 probe that went around the far side of the Moon in October 1959. And you can see one of the pictures there. I mean, it's a pretty grainy picture. These were taken with sort of wet photography that you had to take the photograph, develop it in chemicals, produce it, then scan it as a fax image, basically, and then send it back to Earth. So, you know, it was a triumph for the time to actually get anything at all back from the far side of the Moon. But this is what they did manage to get back. And they even published a set of atlases of the far side of the Moon based on this. It was a great Russian triumph of another sort of part of their space race. Now, we got some much better pictures from yet another Russian spacecraft called Zond 3 in 1965. This was designed to go to Mars and sort of did go to Mars, except it was a couple of months late launching, so it got to where Mars would have been if it had got there on time. But when it got to where Mars was, Mars had obviously moved around its orbit a bit. So it didn't actually get to Mars, but it did get sort of to where Mars should have been. But it flew past the far side of the Moon on its way, and it took much better resolution images. So we actually start to get some reasonable pictures of the far side of the Moon. And even with this resolution, you can perhaps see that it is quite different to the near side. The near side is sort of dominated by these big things we call sea or maria, which are big sort of volcanic outflows that smooth the surface. But they're really not at all evident on the far side, which is something I'll come back to. Of course, there's going to be blips in these photographs, so immediately conspiracy theorists latched onto this, and there was a large statue on the edge of the Moon. It's either yet another castle spying on us, or it could be a sequence of large monoliths if you've ever seen the 2001 A Space Odyssey film, waiting for us to discover them, perhaps. It's almost certainly an artifact of processing, but that never stops good conspiracy theorists. The first thing to get probably to the far side of the moon and land there was something called Ranger 4, which was a US NASA probe. Unfortunately, we have no idea really whether it got there or not. It was launched, went into orbit, and then left orbit to go off to the moon to land on the far side, or I think probably impact on the far side. But very soon after launch, its solar sails didn't unfurl, so it didn't get enough power. And they lost contact with it within a few hours of it sort of losing orbit and heading off to the moon. So for all we know, this is the first object, man-made spacecraft to actually touch down on the far side of the moon or crash into it, but we have no idea. We have no idea even where to look because we don't really know what its trajectory was. So that was what could have been, but wasn't. Now back to just some other key steps in the lunar series. Here's Luna 9, yet another Russian probe. This is the first one to do a soft landing. So this one actually touched down safely onto the lunar surface in a controlled way and could do a little bit of science there, take samples, look at the ground, do some even seismic stuff, I think. So that was Luna 9, the very first soft landing, and quickly followed up by Luna 10, which was the first lunar satellite. This went into orbit around the moon and stayed there for many orbits and even transmitted information back at regular intervals. And was the first spacecraft to actually detect what are called mass concentrations. These are sort of heavy lumps of stuff embedded in the moon that alter the gravity. So as you sort of orbit over these mass cons, the spacecraft is dragged in a little bit more. So this was quite useful for information for later manned missions to the moon, that they could work out some of this from here. Now, 1966-67, you probably all know what's coming up. In 1969, there's a mission to the moon. So at this point, the United States really had to get quite serious about mapping the moon, because they were within a couple of years, hopefully, of landing people on the moon. So they really needed very high resolution pictures of the moon. And they sent up these lunar orbiters 1 to 5 over the course of 1966 to 67 to take very detailed images and maps of the moon so they could work out landing sites. This was actually based on well-tested satellite technology that they'd been using for years, but actually in orbit around the Earth, looking down at the Earth. So these were spy satellites, basically spy satellite technology that they'd honed to sort of perfection, looking at the Earth to work out what was going on around the Earth, that they could adapt for use around the moon. And I think they mapped around about 97% of the moon. They obviously concentrated on the near side, but they also got very good images of the far side. You can see one there off to the right. So that was the sort of most detailed pictures we got up to that date of the far side of the moon. But where there's pictures, there's going to be conspiracy. So some of the pictures they took at quite oblique angles, you can see here, there's something called the tower and the shard, casting long shadows. Again, right at the very resolution of these photographs for some reason, which always seems to be the case. So yet another case for conspiracy theorists. The next big step was Zond 5. Now, this is another Russian probe. You might have remembered Zond 3, the one that nearly got to Mars. So Zond 5 actually went to the moon and came back, but it went round the far side and then came back and splashed down into the ocean. Here it is, Zond 5, but it took with it some passengers, this one. So these were the first living things ever to see the far side of the moon with their own eyes, so to speak. So there was 2 Russian tortoises, a flask of wine flies, some mealworms, some bacteria, some plant seeds, and a few other things. And they all survived the journey there and landed back safely. The tortoises were particularly hungry. Apparently they hadn't packed enough food for the tortoises, so they'd lost quite a bit of body weight when they came back, but they were otherwise unharmed. And although by this point they thought it was probably a fairly safe environment to send astronauts up to the moon, it's always better to sort of test these scenarios. So having tested it with these animals, they were a lot more sure that they could get through there. So as you might have noticed, the US haven't really been featuring quite a lot in this series of firsts. So they were quite behind in the space race leading up to this point. So they had a lot of catching up to do, which was really what I think was some of the driving force behind the Apollo missions. So I'm not going to focus too much on the Apollo missions, but I will mention a little bit about them. So up to this point, Russia was doing really well. They had the first satellite in space, Sputnik, which was in 1957. The first lunar probe we've already discussed in 1959. The first lunar contact in 1959 also. The first spaceman in Vostok 1 with Yuri Gagarin. So there's another first. We also had the first spacewoman with Valentina Tereshkova in Vostok 6, 1963. We have the first lunar soft landing with Luna 9 and also the first lunar orbiter with Luna 10. So a whole series of firsts into the record book. You're going to think this must have dented the pride somewhat of the US people. So they were very, very keen on getting the initiative back, I guess, at this point. And there was a whole lot of other issues around the Apollo program, apart from national pride. So focusing on the Apollo missions, which were destined to go to the moon, these were the ones that sort of drove quite a lot of the early research with these lunar probes. But unfortunately, it does start with tragedy. So the Apollo 1, which wasn't actually called Apollo 1 at the time, this was just a test on the pad of the capsule with a particularly oxygen-rich mixture within the capsule. But something they hadn't quite worked out or overlooked or something. They did have some dodgy wiring in the capsule, which eventually led to the electrical fire that killed these 3 astronauts. But although they tested quite a lot of the stuff within the capsule to be fire resistant, but they hadn't figured on it being fire resistant under a high pressure atmosphere of pure oxygen. So obviously things react quite differently with pure oxygen. So this was the tragedy that befell Grissom, Chaffee and White there, who were, Gus Grissom on the left there was slated probably to be the very first person to walk on the moon. But obviously that all changed when this tragedy occurred and the 3 got burnt in the capsule. But they did pick themselves up very quickly. So this is the test of the Apollo systems. And you can see there, the AS-101 was the very first Saturn rocket in 1964. These were all unmanned tests right up to Apollo 6. And the red line there is the AS-204, which was renamed Apollo 1, which these 3 astronauts died in. So that was 1967. But by 1968 October, they were back to flight status, and Apollo 7 actually launched up into orbit. So that was the first of the Apollo missions. But this didn't get anywhere near the moon, so it doesn't actually move our story on very much. So Apollo 7 was the very first test of this new Saturn V rocket, the Saturn V being strong enough, powerful enough to get people to the moon. Huge rocket that I'll show you the size of it briefly in a second. But so the Apollo 7 launched, went into orbit, did a few tests of the system, that the astronauts survived, that they could sort all the systems out and test everything. So they did a number of orbits around the Earth, and then they did the re-entry and landed back on Earth. So that was the first full-up test of the Apollo system, that they had actually got a new working rocket that seemed to be out in a working condition. So you probably know what's coming next, but I still find it quite audacious that the very next mission, Apollo 8, so this was only the second time they'd used this rocket, brand new technology, they decided to go to the moon. So I think this is, it still amazes me how audacious this mission is, that you have this brand new rocket, it all seems to be working, you've tested it once, let's go to the moon. So a phenomenal act of bravery or national pride or something, I'm not sure what. You have to wonder whether we still have that sort of pioneering spirit in space race, I'm not sure. So there it is, went from the Earth round the moon, did several orbits of the moon. So these were the first human beings to actually see the far side of the moon. And they took this famous photograph of Earthrise as they came round from the far side. They were subject to radio blackout, as we've talked about, because they couldn't talk when they're on the far side. But once they got around there, they could take these pictures. We have video footage and all sorts of other parts and pieces. Just in case anybody wants all the gory details, there we go. And you can look this up on the internet if you really want to know. So the next mission was Apollo 9. So this was another test. So they'd done Apollo 8, they'd gone to the moon. They didn't have any lander on Apollo 8. It was just the rocket with the command module. So Apollo 9, they did take a lunar module up. It wasn't quite the finished item. It was sort of good enough to test, but not good enough to land on the moon. And anyway, they wanted to test this out. So this was a launch into orbit to actually try things out there. Now I'm just going to try stop sharing my screen so I can show you something sort of live, because I got hoping this is coming through okay. Has that stopped sharing? Yeah, you can see me now, yeah? So I have here a Lego model of the Saturn V, which is well worth doing, especially in lockdown, although it is a little pricey. So this is what Apollo 9 was doing. Forget that. So the lunar module was held in this part here. This part here was sort of shrouding containing the lunar module. The astronauts sat up here. So when they got into orbit, they had to shed this shrouding, turn the command module around, come back, pick up the lunar module, and then when they were right ready, they would go off to the moon, obviously, with that. So this is what they were actually testing with this system. And just to show you the size of this, so you can sort of see the size, there is the lunar module. And I don't know if you can see there, you can see two people to scale. So you can see how large this thing is compared to people. Right, I hope I can get back to sharing again. There we go. Hoping that's back. So that was Apollo 9, not really moving the story on very much. Then we come to Apollo 10, and this was a full dress rehearsal for the trip to the moon. So they took the Apollo systems, they took the lunar module, they even went to the moon, they went into orbit around the moon, they separated the command module from the lunar module with 2 astronauts in it, and then they descended down to almost to the moon. I think it was to within 50 kilometers of the moon. It was within touching distance. And I always think this was quite brave of NASA to do this, because all these astronauts are very experienced test pilots, used to flying high technology aircraft, taking risks every day. So if you're 2 sort of gung-ho astronauts in a lunar module, just a few kilometers above the moon's surface, wouldn't it just be in the back of your mind to nudge your colleague and say, shouldn't we just go down there and land and take the glory and be done with it? So NASA had thought about this, and they hadn't actually given them enough fuel to do that and to get back. So that was part of it. And also the lunar module wasn't quite 100% at this point. It was good enough to sort of fly down, but they weren't quite sure of all the systems. So that was that's Apollo 10, and yet another set of astronauts who got to see the far side of the moon. Apollo 11, we probably all know about. Some of us even saw it without giving too much of our age away. So they landed, returned safely, and left experiments on the moon. Then I'm going to skip over to Apollo 17, which was the last of the Apollo missions to the moon in 1973. And this was the only one to take a geologist to the moon. So all the rest had just been test pilots who were, very familiar with high stress situations. But by this point, they had one test pilot, Gene Cernan, and the geologist whose name was Harrison Smith. He was a geologist, and he argued very strongly that they should go and land on the far side of the moon. He said, look, we've seen the geology of the moon is very different on the far side. It would be a very good use of science to go to the far side, examine the rocks there, and get a good sense for what the difference is between the near side and the far side. But he was not successful in that. It was going to be the last mission. It was originally Apollo 18, 19, and 20 planned, but they all got cut through budgetary reasons. So Apollo 17 was the last one. And I think NASA took the prudent decision that if this was going to be the last mission, let's try and do something that's going to end up on a high note rather than something a little too risky. So he never got to go to the far side. However, this did lead to more conspiracies, and it actually came about from Apollo 12. And the idea started to float around that the moon was actually hollow and was just a giant spaceship that was covered in rocks to disguise it, and was inhabited by aliens. And part of this came from the Apollo 12 mission, because after the astronauts from Apollo 12 had come back and got back into the command module, they jettisoned the lunar module and crashed it into the moon on purpose to trigger sort of seismic waves, because they'd already put seismometers on the moon so they could work out a bit of the geology. So it crashed into the moon, and the report is that the moon rang like a bell for over an hour. And obviously, for something to ring like a bell, it has to be hollow. And this sort of backs up some of history. At some point, Edmund Halley, back in the 1600s, thought the Earth was hollow, but this turned out to be a mistake in Newton's calculations. But in fiction, H.G. Wells, one of the early science fiction writers, in his trips to the moon, he had the astronauts in his fictional account. They went inside the moon to meet the moon beings. But it was really given credence by these two people from the Russian Academy of Sciences, who actually wrote an article saying that they thought the moon was hollow and was a spaceship. And that got several people thinking. I think most scientists disregarded it, but there's nothing like a couple of wacky scientists coming out with a crazy theory to get everybody thinking that. And this is actually still true. If you go to Amazon, you can find this book on Amazon store, Who Built the Moon? This is a review given by the Daily Mail, which is yet another tabloid paper in the UK that is also not renowned for its journalistic integrity. So I wouldn't believe everything they put in there either. And of course, if you've seen Star Wars, you know that "that's no moon" is definitely a phrase that crops up. So as far as the moon goes, we haven't done a lot since the Apollo missions. There's been the occasional sort of flyby and trip past it, but the most significant thing of recent times was the LRO, the Lunar Reconnaissance Orbiter of 2009. This is a high-resolution mapping mission, obviously using digital cameras and digital technology now. So this has the ability to map the moon to a very high degree. It has two principal cameras, one with 100-meter resolution, that's used for the sort of major mapping, and one with 0.5 meter resolution that you can focus in on any sites of particular interest. So they've done that. So here is the Apollo 17 landing site, photographed from orbit by the LRO. So you can see there the various parts they've been, including the moon buggy tracks, the astronaut tracks, and even the flag there casting a shadow. So this gives us quite good detail, but obviously as it orbits continuing around the moon, we get our best images yet of the far side. And here indeed is the far side in all its glory. And you can see really there are very few areas. There's perhaps one to the left there that might be considered a sea, but the rest of it is just a mass of craters, all not unlike those on the near side, but we just really don't see those large areas of volcanic outflows that you see on the far side. So we've nearly come to the end of our trip to the moon. But there was one more mission, Chang'e 4, the Chinese space agency. They sent a probe to the moon, and this is the first ever thing to land on the far side of the moon, and also contains a rover. So it landed softly on the far side, and then a rover went out and started to explore the far side of the moon. And this used this L2 point that I talked about earlier on to park this satellite there that would relay the information back from the lunar far side back to Earth and to the Chinese Space Agency to contain the data and pictures they'd taken there. And they don't release an awful lot of information, the Chinese Space Agency, just sort of what they feel they ought to, compared to people like NASA who release an awful lot. So this is some of the images they've sent there. This is a short sort of movie clip from them of the Chang'e, that's actually called the U2 rover. And it has a drill there for drilling into the lunar surface and taking samples and inspecting the geometry. Here's some video footage of it moving off the lander, and then the rover looking back at it. And just to sort of highlight everything, they released this picture which shows all the places people have landed, objects have landed on the moon. So you can see there lots and lots of things on the near side and only one thing on the far side. So that's where Chang'e 4 and the U2 rover landed. Yet again, tabloids are not taking this line down. They're going to always say that there is perhaps some fakery or some conspiracy theory, but really there isn't, because the Lunar Reconnaissance Orbiter knows where this is and took this high-resolution photograph of both the Chang'e 4 and the U2 rover. So we have independent views that that's there. And they've actually done some really good science with there's a Nature paper here published of the team comparing the difference between the far side and the near side structures. And it's still going. So it chugs along the lunar surface. As I said, it's a 14-day day, 14-day night. So with its solar panels, it moves around during the day, lunar day, for 14 days. And then it shuts down into sort of hibernation during the lunar night, and then wakes up again for the next 14 days. And you can see there, that got as far as December 2019. But the latest reports I saw was the end of May, and it was still patrolling around the moon at the end of May. So it's still doing some good work out there. But now it does seem that it's almost open season on the moon. Lots of people are talking about going back to the moon. This is Chandrayaan 2, the Indian Space Agency. They sent a mission to the moon with their lander Vikram and the rover Pragyan. I'm not too sure about that pronunciation. Unfortunately, this didn't make it. It crashed in the last few stages of its final maneuvers. Then Israel have also sent a lander to the moon called Bereshit. This one also crashed on the way to the moon, but again got very close. It got within sort of a handful of kilometers really before it went out of control. And I don't know if you can see anything here. This is a before and after. You can see just in the middle there a slight impact, both from the Vikram and the Bereshit missions. So just to wrap this up, because we're about at the end here, there's a few questions still to be answered. And I have to say, quite a lot of this is my speculation. So do not go around saying, I know what's going to happen to the moon based on what somebody in Nottingham has told you. I don't know anything about it. This is just my guess and perhaps my wishes for what we'd like to happen. But there are still some things we need to know. Why is the far side of the moon so very different to the near side? And when you put them right next to each other, they do look distinctly different. One idea is that the moon shields, the Earth, sorry, shields the moon from meteor impacts. But if you do the calculations, it's only 4 square degrees of sky that the Earth shields, which is really very little sky that it's shielding. So that's probably not the answer. What the answer may well be is that the far side is much, much thicker crust than the near side. But this doesn't really help us any, because now we need to know, why is the far side thicker than the near side? We could probably explain that volcanic activity is likely to get onto the near side through the thinner crust, but that just pushes the problem back one stage. And there are a few papers around about this, wondering what the scenario is. Perhaps it might be something to do with the formation, perhaps something to do with tidal locking scenario, but I haven't seen any convincing answer to this that other people have said, oh yes, that's obviously the case. So that's still yet to be done. One thing I think I'm fairly confident about, was it a home for aliens? Probably not. I'm going to go with the science result to say nothing is ever proven conclusively, but it's probably not a home for aliens. We've looked at it in enough detail now to be fairly sure. But what could we do with the future? Well, again, this is my personal opinion. You may well have lots of different ideas about this, but I think if we're going to go out into space as a species, colonization of the moon is the simple first step, really. People do talk about going to Mars, and there are a few benefits to going to Mars, but there's a lot more benefits about going to the moon. For beginning, it's only 3 days away. So if you get to the moon and you've forgotten something vital, as long as you can hold out for 3 days, you can probably get new supplies. Mars, it's 6 to 9 months to get to Mars, and it's even worse than that, because you then have to wait a year for Mars and Earth to get back into a favorable conjunction so you can do the return journey. So you have to solve a lot of the same problems living on the moon as you do Mars. You have to be able to make your own atmosphere. You have to be able to shield yourself from radiation, particularly solar radiation. The Martian atmosphere is really not thick enough, and it doesn't have a magnetic shield like the Earth does. So you're not really shielded very much from anything by the Martian atmosphere. So you might as well solve those problems on the moon. The other thing is, if you can find something useful to do on the moon, such as manufacture or mining or something like that, the cost of getting from the moon to the Earth is almost trivial. This is just a graph of the amount of energy you need. The blue one is the amount of energy you need to get off the Earth, I think for a kilogram of material or something like that. I can't remember, but it doesn't really matter. These are sort of relative numbers compared to the moon. So you can see there, it's a really tiny amount of energy you need to get off the moon. This tiny, tiny lunar module was powerful enough to lift 2 astronauts off the moon, get them back into lunar orbit, and mostly on the way back to the Earth. In fact, in the case of Apollo 13, it was almost all of that. So if you can find anything useful on the moon, and people have talked about collecting helium-3, perhaps even mining asteroids that have collided with the moon and getting rare metals from those, then the cost of getting it back to the Earth is very small compared to getting from the Earth to the moon, if you see what I mean. And you can see there for Mars, it's somewhere in between. It's pretty easy to get off Mars compared to the Earth. Earth is a really massive gravity well to get out of. So yeah, as I said, you need something this big to get off the Earth, something only this big to get off the moon. As we're all astronomers, the moon telescopes on the far side is the perfect place to put telescopes. You are in almost the best possible location to have telescopes. And it's not a new idea. If you've read any science fiction, you might have come across Arthur C. Clarke in one of his books called Earthlight. He has, which is quite an interesting, fun read anyway. But it's all set around a moon base, which is occupied mostly by astronomers, and all the serious astronomical instruments are now on the moon, because why not? That is the perfect place. This is the great place for the moon, because all these things: no cell phones, no clouds, no atmosphere, no Starlink satellites going overhead, and no light pollution. And you're blocked from light pollution and extraneous radio signals by the bulk of the moon. And indeed, there was a meeting supposedly organised. It was actually the beginning of March in the UK at the Royal Astronomical Society. It was a sort of brainstorming meeting for putting a telescope on the far side of the moon. I think it was probably, I wasn't going to go, so I didn't actually investigate it any further, but I think they were looking at putting a radio dish in a crater, basically. All done remotely without astronauts at that point, and looking at the feasibility of it. So for my money, that is the way forward. That's just my speculation, but that's what I'd like to. And I think I'd be willing to go up and tweak the odd mirror here and take the odd amount of data there if I was asked. I don't think I'm going to be asked. I'm probably far too old. Anyway, that's my speculation on it. I hope you found this at least entertaining, if not particularly science-rich. But anyway, thank you for your attention, and thank you for listening.
Thank you very much, Julian. That was interesting. If we have any questions, can people use the raise hand function so I can see them? In the meantime, I have a question. You mentioned about how there's volcanic outflows on the near side of the moon. Is there expected to still be volcanic activity and tectonic activity within the moon, or is it completely dormant now?
It's almost completely dormant now. I think that those happened very early on in the moon's history, when it still had some amount of molten stuff. There is a bit of tectonic activity picked up by seismographs on the moon, but they think that's mostly sort of the residual heat coming out of the moon, and it's sort of slowly collapsing in on itself very slowly. So I think it's that sort of thing rather than sort of active volcanism or active magma, that sort of mechanism.
Yeah. Okay.
Thank you for
that. Someone has commented in the chat that there's already a Chinese telescope on the moon. Do you know anything about that?
Chang'e 4 had a small telescope within it, so I think, I'm not sure if it was a UV telescope. So as part of it, it had a telescope on it, so it could take readings. So I think UV was probably what they were going for, because there isn't a lot of UV coverage, but it's going to be pretty small. It's going to be sort of inches or millimeters rather than meters or feet. So yeah, I think it did have a telescope on it. So yes.
Ooh.
And yes, the Saturn V model somebody's mentioned there. You have to be quite quick, because Lego have stopped making them. They sort of have a regular turnover. So when they go into that stage, the price goes up quite a lot. Actually, I haven't brought my other model. They also do a lunar module. So this is the lunar module that comes with it, but you can get a full-scale lunar module. It's in the other room. Should have brought it through.
Nice.
Yes, that's the Apollo 1, and it's great fun. It's really quite robust, and it has 1,969 pieces. So 1969 for the date it was launched.
Perfectly engineered.
Perfectly engineered, exactly.
Oh, cool. So I noticed that Gaspar has his hand up.
Yes, thanks, Julian. Very interesting talk. I have perhaps a very basic question that has been in the medias since many years. What about the water in the moon? I mean, and what would be the role of comets? Always we talk about some meteorites that ride to the moon, but what about comets, small comets or whatever that could eventually give some water into the moon surface?
Now, that's a very good question, because water, certainly if you're going to go there, water is probably one of the things you would look for very early on, because water is really heavy to take to the moon. So there is quite a lot of water. Excuse me. There's quite a lot of water on the moon. There's some in the south polar craters. There's some craters there that never see the sun because the lip of the crater always shields the sun. But there's actually quite a lot bound up in minerals. So there's, I'm not very good on geology, but there's certain minerals that have water chemically bound to them. So you can chemically unbind them, sort of like clays and things. But in the chemical books, they have a sort of an equation with a dot and H2O stuck onto the end. So there's a group I know at the Open University in the UK that have done quite a lot of work on this, and they think there's quite a reasonable amount of water on there. Not enough for oceans, but if you're going to go there and you want breathable oxygen, hydrogen, and water to, because hydrogen makes great rocket fuel, you can get all these things from the water in the minerals. And they're fairly well spread across the moon, from what I understand. So almost any place you go to, there is a certain amount of water you can get, but it's not just lying there. You have to sort of chemically extract it or heat it up to high temperatures. But I guess power is fairly cheap on the moon, because you've got a lot of solar radiation that you can pick up, at least for 14 days, and then you go into lockdown, I guess, after that.
Okay, thank you, Julian.
There about their impact. How long did it take for Moon to assemble into something fairly spherical? I have to say I don't know the answer to that. I think it was fairly quick. And there's some speculation that we may have had rings around the Earth for some short time, a bit like Saturn, before they coalesced into a body.
So another question has just popped up in the chat about
space politics. Oh, yes. Now, this is really interesting one. I went to a talk on this in London back in February by a lawyer. So I should have taken more notes. But apparently there is something called the Outer Space Treaty that a lot of countries have signed up to, that basically says that the outer space is a bit like Antarctica. It is not under one single domain. Anybody can go there for scientific research, but you shouldn't be exploiting it for wealth and things like that, or not without agreement between all the signatories. The big problem with that is, A, not everybody has signed it, and B, how are you going to enforce it if there's only a couple of countries that can get to the moon and start mining it? You can sort of waive all the bits of legal paper you wish and say, you should not be mining the moon. You can perhaps think of things you can do to him on Earth, but you're not really going to be able to stop them if they're the only people who can go out there and mine it, or do whatever else they want with it. So I think that is somewhat of the driving force behind sort of the new ideas of going back to the moon. The US have said they'd like to go back by 2024. Personally, my personal opinion, I think that's a little ambitious, given the state of US rocketry at the moment. They've only just managed to get astronauts back to the space station, so getting to the moon in another 3 years, I don't know. I'd love to see it happen, but I think it's ambitious. So I think that is somewhat the politics driving going back to the moon, is that if somebody, just to pick on China, if China go back to the moon and they have said they would like to go there, if they start to go there, start to build cities and things like that, that is again a bit of an issue that other countries might take. They've got it all to themselves now. We need a piece of this. So yeah, it's a really vexed issue, and I don't think it's going to be really sorted out until there are actually people on the moon and you can actually enforce these things.
Yeah.
And Space Force.
Space Force! Of course. Why didn't I think of Space Force?
So I have a question about the radio telescope discussion that people had recently, right? So I think the main advantage, as far as I'm concerned, would be to get actually the baseline for spanning a nice interferometer, right, between the Earth and the moon base.
That would be, yeah, you could do really
Instead of
very,
getting
very
plugged.
long baseline
Yeah, exactly. Yeah.
interferometry. The other good thing you could do there is really low,
Low frequency.
low wave, small wave, long wavelength, because that is blocked by the ionosphere, obviously, on Earth. So you could, I don't know there's anything interesting out beyond that. Could well be distant redshift things, being shifted into that band. I don't know. But if nobody's looked there, obviously there could be gold in that there wavelength. If nobody's had a big enough radio telescope to look there outside of the Earth's atmosphere.
Yeah, technologically, I think that would be also a very easy setup, right? Because you just dump antennas; they don't have to be like perfectly aligned, right? You just need to connect them somehow and read them out continuously.
Yeah, quite. If it's sort of kilometer wavelengths, then it doesn't really have to be flat at all, does it?
Yes.
Ah, we should go there. Let's do it.
We should go there. Let's go tomorrow.
Okay, if there's no more questions, then I'd like to just say thank you again to Julian on behalf of everyone. Thank you for giving up the time. I know it must be close to 9:30 at night in the UK. So I hope everyone's enjoyed the talk, and I'll see you all in August for the start of the next semester of the colloquia. Ciao.
Ciao. Thank you for inviting me.
Thanks.
Bye.
Ciao, ciao. Ciao, ciao.